thanks for Kamiński, who helped me with some code, some slides, a little bit. I'm immensely grateful to him. And let's start with the plan. I will first try to explain what is the problem that we have and that we're trying to solve. How does the import mechanism work? How you can write your own import hook and import stuff from places. Then we will demo it. Let's hope the demo goes graceful to us today. And I will show some, but it didn't show that I will explain some. We'll talk about some uses of the import mechanism. So first, what was my own motivation for coming here? So maybe if you remember me from last year, well, that's me, I've done a live talk about creating a new game mode. I could write some code for the game Arma, which involved creating a embedding Python into the Arma game. I've spent around 5 minutes, 10 seconds explaining the embedding part, and this is what, well, it was not, I didn't talk much about it. And, well, I needed, for that part of my job there, I needed to import some files into the game. When we have Python that's running inside the game, we don't want the files to be scattered around the file system. So I needed to import them the way I wanted to. And also, when I asked my friends how to do that, because that was just a mod. That was just a mod that I was making. It wasn't really for my day job. So I asked them how to do that. How did they think I could handle this thing? They said, that's simple, just use import hooks. There's a mechanism in Python that does that. Oh, okay, import hooks. Nice. How does that work? Well, just read the manual. We don't know actually. We never used it. We just know that it exists. So this is basically what everyone told me. Everyone, maybe not everyone, but most of the people knew them. But when it came to actually using them, they didn't really know how. And also, I've been told that years back at Python PL, there were some people who were talking about importing Python code directly from a database. So that got me interested. I started asking people about that talk, and I've been told is that yeah, they showed maybe I don't think they haven't even showed it, but they just talked about it and they never released the code. So we have those import hooks that no one knows how they work. We have people who have done that, but they haven't shown the code. So I thought maybe that's something that I can do right here and right now. Anyway, the best way to import your custom code is that you create a function that is a module name, and then you fetch the file contents somehow, and you add all the contents. Thank you, goodbye. Nice for you to have stayed until then. Do you have any questions? Yeah, of course, but please don't leave yet. That's not true. This is a really specific idea. Actually, not because there's an eval there, because we don't use eval mostly because we don't want to run unsanitized code from the user, but in this case that's not really an issue for us, because we have to assume that all code that we will be fetching will have to be executed anyway. But anyway, what's wrong with that eval? The thing is that you have your custom importing function that you have to execute. I mean, you have to type custom import stuff. You cannot just do import stuff or from stuff import other stuff, because, well, that's not how it works. And then your code, as a matter of fact, has to be aware that it is imported in some other way, and if it has some imports itself, which it probably does, then it has to import those things in that special manner using your custom function, which is which is not what you want to do if you want to run code from maybe not from the internet, but from packages in general. So also a quick primer on how importing works. I hope that you all know that, otherwise I'm not sure what we're doing here, but for the sake of completeness, we have those directories. A directory parent, that is a package. It contains two packages, the package name 1 and the package name 2. And inside the package name 2, we also have a module that is called and a half. So what will happen if you import those packages? First, you will have, in those files, I've just written some print statements so that we know that the code inside is executed. So when we first import parent.1, what happens is the parent module is first imported, as you can see the parent line. Then after that, after the top module has been imported, we can import the one module. Those modules are then stored in the sys modules dictionary, and they are there as a cache. Then when we import the 2 module, the 2 package actually, we can see that only 2 has been written down. That's because the parent module has already been imported, so it's not imported anymore. And then when we import the n.half module, well, as you can see, only n.half has been written. What we will need also is, well, let's take a look at the glossary of the Python docs. To import things in Python, we need finders and loaders. A finder, that's an object that tries to find the right loader to load the module. So we first check all the finders with a module name that we want to import, and when a finder tells that it can handle the module, the loader, its loader that the finder returns, will start working. The loader is an object that actually loads the module and executes the code that's inside the files. It is typically returned by a finder, well, you will see how you can make both finders and loaders, implement them quite easily. Also, the thing is that most of the time you don't need separate custom finders and separate custom loaders. You can just use them in one class, and then that class is called an importer. It's just one class that has all the functions that are, all the modules, all the methods that are needed to import the code. So, how does importing works? How does it work? Maybe not in depth, because if you're really interested in how in-depth importing is, you can check the talk from 2016 or 15 of PythonPL on YouTube. I recommend that video. So, first, when you type import something or from something, import something else, the canonical name is created, which is the, as you can see, parent package, subpackage module, by mostly compensating the strings. Then, sys modules is checked if that module has already been imported. If it has been imported, then nothing happens. That module is just returned, and the other code continues. Otherwise, as I said, you check all the finders that have been declared. You go through all of them, and once any of those finders returns to Python and says that, hey, I can handle it, then the loader code is being run. Yes, so this is what I said actually here. The finder has to implement the find spec method. That method may return either none, and this means I cannot handle this module. There's nothing to see. Carry on. You can raise an exception, then well, that's just an error, and it means that something that happened. Or you can return a spec object which will contain the loader to use later on. Yes, so if all finders is returned none, you have the module not found error, which means that you have probably made a typo, and otherwise the code continues. If you want to load the module, you will need to have one or two minimal modules, methods. One is the create module method, and it can return none. In this case, the module will just be created by the Python import machinery, which I suggested to do at the start, because you don't really need all the fancy things there. And then you need to create the exec module method, which will execute the code that has been imported by your loader. Also, you may find, if you search through the web, you may find some other importers and loaders that use load module. It's a deprecated function. It does, exec module does what load module does automatically. If you create the load module method, then you'll have to do some other, well, you have to run some boilerplate code. And hence exec module was born. That's a really lot of things to do and to remember, but fortunately they are not really needed for you to create your own import module, because enter import list ABC. This is a module that abstracts lots of things that you can use to create your own import tools easily. It gives you lots of classes that can be reused. There are, for each their own, I would say. You can create a meta path finder, you can create a path entry finder, and for the loaders, there are some you can hear some that haven't been placed on the slide, but you can check them all in the documentation. But what we will need for the minimal example is the meta path finder and the source loader. The meta path finder is a finder that you have to store in the sys meta path array, and you have to just create one single method inside. It's the find spec method. The find spec method will just will take a full name of the module, which is the package.subpackage.module string, the path and the target, which are not really needed right now for the minimal example, and it will return your spec. This is how it looks. That's mostly boilerplate code. You create your class, you use the meta path finder, and inside we will just write that we are trying to load something. We have to check if you can import, if that finder can import the module or not, and it can just return the loader. From this boilerplate code, what you need to implement yourself is the can import function or method, the myLoader, obviously, because you will have to use a loader for all those things, and another function that will say if what we are asking to import is a package or if it's just a module. A package can have sub-packages and modules inside the code. So that's the finder part. And for the loader part, we can use the source loader, which it's a class for implementing source file loading. two methods that you have to implement is the get file name, which takes the module, the canonical name for the module, and returns the virtual or not file name that will contain the code to be executed. And the second function that we need is the get data method that will take a path, your virtual path or maybe your real path, and it will return to Python the string that contains the code that would normally be inside that file. And also note that you can skip the file name part, and you can even create loaders that will return bytecode directly, which means that your code is not really portable, but you skip one step, which may be faster for you. For example, if you just store the bytecode already compiled somewhere. And also you can load PYD files, which means that if you have some extensions, CPython extensions, for example, you can reuse those as well and use them just as if they were regular files on your file system. This is just for completeness also, because there is not much code here. You have the get file name method and the get data method that contains a print, and those two functions will actually need to be filled in with your custom code that you want to have. And if you decide, that's what I said before. You can have the loader and the finder in one single class, and in which case you just inherit from those two classes, and you create the three methods in this exact same way as it was before. To install your hooks, what you need to do is to add the finder or the importer to the meta path. You can do that by inserting it at the first position, or by appending. Well, it actually depends on what you want to do. For example, if you want to override the whole import mechanism of Python, you will want to insert at the first place, because then your importer will take care of everything. Or you can, for example, append at the end, which means that if other importers cannot import your type of module, only then your importer will run and try to do its magic. So now let's show how it works. We have the demo here, and what I've done is just a simple. For now, so here in the demo file we have a virtual, let's say, file system contained inside data, the dictionary. What this means is that we have this file inside this directory, and this is the contents of that file, executing or intercept modules in its file. The get file name function is a function that actually checks for a module name. It replaces the dots. You don't really need to care about it. What it does is that it replaces the dots in the canonical name with slashes and checks if we have custom module.py inside our data dictionary, or if it has custom module /dunder_init file. If we have dunder_init, which it means that it's a package, otherwise it means that it's a module. That's what's returned here. Then we have that importer that uses the file name to import, to get the file name, obviously, and we access data from the getData method, and we can assume that this function will not fail because otherwise getFileName would have failed previously. And our findSpec method for now just accepts all the important. It takes all the modules and tries to import all of them. And what it does is that it just returns self because, well, it's an importer, so we don't have two classes. If we have an finder and a loader, here we would have returned the loader. And as I said previously, the is package value is here. Then we install that importer, and we try to import the custom module. So this should hopefully execute this line of code. Ta-da. So what we have here is first the find spec module, the method that is executed. It's trying to load the custom module, this is the file name function that is called, and it checks for the init_by or the custom module.by function existence in the data dictionary. It returns this string, and hence our loading part then fetches this file from the virtual file system, and it executes it. And this is the code that has been executed from the virtual file system. This is one thing that I wanted to show, and then Janusz, could you come here? Then we will see how to write another importer. Like for example, if we'd like to import something from let's say GitHub. We want to access files that are directly inside on GitHub files. So for example, let's say so for example, the GH processor file here, you can fetch it by issuing an HTTP request to route it to GitHub user content, evaluate something GH processor file. So we will start with a simple template here. What I have here is the template that I talked about. This package is not implemented. The find spec is missing things. The loader is missing things. The get file name method and the get data method. This is something that you can start with if you want to create your own finder, loader, or importer. So also I have reused some functions here. This is a simple function that fetches code from the internet, from using the HTTP, well, using the request module, you probably know it. If it finds a page, it returns its contents, otherwise it returns none. This is what we're going to use to check if this is if we have a package or if we have a module. And also create a URL function that, as you can see, it just puts in all the pieces to create the URL that we will be using. And one thing is that is important is that when we will import from github.rebellious.by github import.gh processor, Python will have to import all those modules in order. So first it will import GitHub, then it will import github.evaluate, which means that it will try to fetch some. It would have tried to fetch evaluate.py or evaluate/donor init, but this is something that we want to prevent. So this is we will just, as a workaround for here, we will just return a fake page that we will always say this does not have any .py file. Anyway, back to the init part, what we want to do is first check if something is a package. So what we do here, we need to create a base URL out of this. So and after that, we just check if we can find a .py file. So we do a get GitHub URL plus .py, and if what's returned is none, we return that it is in fact a package. We assume that. Normally we should also test for the Dunderpy results, but to simplify things, we will just do that. And otherwise, of course, return false. Please double check what I'm doing is correct. Here. That's the first part that we have to do. The second thing is that we don't want to import other modules, meaning if we do import sys, our finder will not fire. So what we do is if not name starts with GitHub, return none. This will prevent trying to import all the sys, OS, path, and stuff. Otherwise, we return our loader, which is here, and what we have to do is first check if it's a package. So here's package full name. We return name. We have to create our base URL here. And then we return, if it is a package, we return the URL plus number in it. And it's fine. Otherwise, if it's not a package, we just return. We just return URL plus the py stuff. When we know which file name we want to import, what we do is we get the data. Of course, if we have returned the fake address previously, we don't want to actually fetch that address, but we want to say that the module does not have any data inside, and then we just get the file from GitHub, which should be GitHub. File name, and then we install the module. And now we're across. We can try to import Janusz's module that is contained. Well, we will find not open it, but it's just a small code that executes, and it does. Okay, just print some things. Let's hope it will work. Sorry?
Tap on the data.
Tap on the data.
There's a wrong indentation on the first line of the data. No, about line 40.
Line 40.
What do you mean?
It's not in the class.
Ah. Yeah, sure. Thank you. Let me press again. Since it's working. So now we are fetching GitHub data and stuff is happening. So this is our working, this is a module that, an importer that imports your data directly from GitHub. Also, what's interesting is that someone has thought about bringing this to a whole new level. Have you heard about Stack Overflow based programming? It means that if you have a problem, you just go onto Stack Overflow, you check for, you search for an answer, you copy the code, you paste it inside your file, and you pray, and you hope it will work. So that big guy just brought it to a whole new level because he thought, hey, why should I search for it? Why should I copy it? I can just fetch it directly from Stack Overflow. So what is there is the Stack Overflow import. I had to make some small changes for it to work right now. For Python 5 and above. But anyway, this is that's his code. And the thing is that it is on GitHub currently. So what we could do is we could do an importception, meaning that we will import his own code using our importer from GitHub, and then use that to, for example, I don't know, sort some numbers. And this is the image.py file, which should work hopefully now that we have imported. But we have imported the QLOL file successfully, which means we'll first import the Stack Overflow module from GitHub here. Then we will remove our workaround because this is all dodgy stuff. What we're doing here, so we will just remove our GitHub importer so that it doesn't interfere with other small importer. And then what we do is from Stack Overflow we will import a sorting function here by doing this. So from our module import query, we will get an array to just sort it, and then we will sort it. So what we do now, let's hope that the right answer hasn't been downloaded in the meantime. Alright, so what we have now, what we should hopefully have now, let's check, it's the quicksort module. So yeah, this is our module. What we have here is we can check what it contains. It contains a quicksort method, but we would like to know what it does, that method. So we just use the help function. Quicksort. The name is like that because That's the name of the function that is in the quicksort template. The quicksort Stack Overflow answer that is the most voted out of all the most voted questions on Stack Overflow. Usually this works faster, but I'm using solar connection. And you can see that this is the function that we want to use. Somehow the guy had to use the self for argument, but since this is just a function, we'll just pass dummy values. We have the args that is here and has to be sorted. So what we will do is just quick sort, quick sort, no, that's the self part, and args. And we managed to an array without coding anything ourselves. Yes, so let's go back to the presentation now. So what are the uses of custom import mechanism and import hooks? So first you can store the Python code in a database. Honestly, I'm not really sure why they did that, but they must have had a reason. You would have to ask them. What you can do, but what I know you can do is you can generate the code on the fly, for example, per requester, which means that someone imports a file, a module, and depending on, I don't know, its IP or whatever, you can give him some other code than you have given to another user. You can generate the code based on the time. It's all dynamically. It can use some virtual file systems as we have shown here, but you can also generate the code on the fly, which means that you can have some things like tokens that will have to match your Python code that you give away to people, and without that token, your software will not work. What you can do is, if you want to put your Python code inside an exe file, you have PyInstaller or PyExe for that. But if you want to create your own executable without using PyInstaller or PyExe, you will want to use import hooks. Actually, I've checked the PyInstaller code. That's mostly what they do to prevent accessing Python that is on the computer, and instead just use all the Python, all the embedded Python files, modules, and packages. You can have the code stored in a proprietary format for Python in those embedded applications, as I had the need to do, that I said at the very beginning. You can have some, even if you want to, I'm not advocating for it, but you can have, you can try at least to DRM, which means that what I wanted to show, but I didn't have the time to prepare that, is an Arduino. It's an Arduino that would have a button. And if you try to import things, it will communicate through the COM interface with the Arduino. And if the button was pressed, it would just run some code. If the button was not pressed, then you would get an import error try harder, for example. And speaking of try harder, that's probably a good idea to implement for some CTFs. If you want to dig into that topic deeper, well, I suggest you to first read the Python documentation, but of course, well, it's not really obvious at first sight. Hopefully, the template that I have provided in those slides will help you understand it easier. What I also suggest you is to take a look at PyInstaller at that file inside the PyInstaller repository, because what's interesting is that in PyInstaller, PyInstaller has to work with various number of Python versions, which means that their code is much more complicated, but you can see that some functions are used for Python 2.7, some functions are used for Python 3.4. This is an interesting read if you don't want just to have that importer implemented and done with. If you want to learn a bit more about the history of all those things. And also, those are our two libraries that have been, the first one, mined by my library, has been shamelessly stolen from my guide that you can just check on GitHub from where it was imported, because I had to make some changes for it to work better with importing from GitHub. And also I get the GitHub importer that we have implemented today is also visible, possible to be downloaded down here. So this time for real, thank you, and you can go crazy with this, but not too much, not on production, hopefully. And do you have any questions? Well, the practical, other and practical usages of these features besides Stack Overflow, well, I hope I explained that. So this means things like PyInstaller, like storing your data in some proprietary format, and also other uses. The other question is, can I use import hood to block some imports? Let's say I'm in a module a.sum. I want that from B import other statement raises an exception. Or what you can do is you can make an importer, and then you can place it, you can just insert it at the very beginning of all those importers, which should be, let me check, here. You just do a sys metapath insert 0, and this will ensure that your importer, your finder or your importer will be called as the first one before even the built-in Python importers are run. And then once your importer is running, what you can do is just raise the exception. You just check the name of the module that is being imported. And if you don't like it, you just do raise import error. Can you overwrite imports? Is there a way for malicious behavior? Of course, there is a way for malicious behavior. That's why you should not run untrusted code from Stack Overflow. This is exactly the same thing as with eval. If you let someone else execute his code on your machine or inside your program, you're going to have a bad time. So what you have to do is, you have to ensure that the code that you are running is sanitized. It's not some magical thing that will allow you to run the code from your users. It's something that allows you to run your own code in a way that makes things simple for you, that allows you to store things in different places, but it still has to be your code. Please do not use the Stack Overflow importer. Really, that's not a good idea. Do you have any questions from the audience? If not, thank you very much.